A spacecraft passes over a small moon orbiting Jupiter. And suddenly the cameras detect something impossible. A plume of fire rising hundreds of kilometers into space. Then another. Then another. Entire continents glowing in infrared. Lava lakes larger than countries. A surface so violent that the ground itself is being continuously destroyed and rebuilt beneath the instruments recording it. When the data arrived at NASA, even the scientists who built the mission paused, not surprised, stunned. Because what Juno detected on Io shattered every volcanic record in the solar system. And the man who led the mission looked at those numbers and said, they blew his mind. When the scientists who designed the spacecraft say that, you know something has happened, that has no precedent anywhere we have ever looked. This is Io. And what NASA found there raises a question scientists still cannot fully answer. What is actually happening inside this moon? Most people have never heard of Io. Those who have picture a small orange moon quietly orbiting Jupiter. Peaceful, distant, just another rock in the darkness beyond Mars. That image is catastrophically wrong. At any moment, more than 400 volcanoes are erupting simultaneously across Io's surface. Lava fountains burst from the ground like geysers of molten rock. Entire regions are flooded and buried before meteor impacts can even leave a permanent mark. On Earth's moon, a crater can remain unchanged for billions of years, but on Io, an eruption can bury that same crater in months. The landscape you see today may not exist next year. The moon erases its own scars faster than the universe can create them. Io is not a quiet moon. It is a world on fire, every single day, without pause, for 4 billion years. And the reason it burns has nothing to do with the sun. Every orbit around Jupiter stretches Io like a stress ball in the hands of a giant. The surface rises and falls by tens of meters. Mountains flex, the crust fractures. The entire moon is physically bending as it travels. Io is trapped in a gravitational battle between Jupiter's overwhelming mass pulling from one side and the neighboring moons Europa and Ganymede pulling from the other. The constant squeezing generates heat so extreme that it melts rock into magma continuously. Deep underground, that magma finds cracks, and eventually the pressure escapes in explosions across the surface. Jupiter did not just create Io's volcanism. Jupiter is Io's volcanism. Every eruption on that moon is invisible, gravity made violently visible. From orbit, one feature dominates the surface immediately. A dark circular scar almost 200 kilometers wide burned into the landscape. This is Loki, Patera, the largest active lava lake ever discovered anywhere in the solar system. Around its edges, lava glows at over 700 degrees Celsius, hot enough to melt aluminum. But the floating crust covering the center of the lake cools rapidly, dropping to freezing temperatures. Beneath that frozen surface, a molten ocean waits. Eventually, the crust cracks, sinks into the magma below, and disappears completely. A new crust forms above it. The entire lake constantly renewing itself. A breathing ocean of fire spanning an area larger than many countries, Juno's infrared imager captured it in thermal detail never previously achieved. Bright glowing rings pulsing against darkness. An alien structure breathing with heat across hundreds of kilometers of molten rock. Then there are the plumes. Io's eruptions launch material hundreds of kilometers above the surface. Commercial aircraft fly at 12 kilometers altitude. Io's plumes tower 20 to 30 times higher. Umbrella-shaped clouds of sulfur and silicate ash raining back down across thousands of square kilometers, repainting the surface in toxic yellows, oranges, and reds after every eruption. Io does not just erupt. It redecorates itself continuously in sulfur chemistry that looks more like a poisoned painting than any moon we have ever seen. In January 2026, Juno made a flyby that stopped NASA scientists completely, not one of the close passes. A more distant observation that somehow delivered the most shocking volcanic data in the history of space exploration. Scientists ran the energy calculations from that flyby. At first, they assumed the instruments were wrong. They checked again and again. The eruption was producing energy at a scale nobody had ever encountered on a solid world. The final number was staggering: 80 trillion watts from one volcanic system on one moon. And it was not coming from a single volcano. Multiple volcanic centers erupted simultaneously across a wide region, connected underground through a network of magma like a planetary nervous system firing all at once. A chain reaction, dominoes falling across an entire hemisphere. Scott Bolton, Juno's principal investigator and the man who built this mission, said the data from that flyby really blew his mind. This is a scientist who has spent decades studying the most extreme environments in planetary science. And even he had no reference point for what Io produced. But the eruptions do not stay on Io. Some of Io's volcanic plumes blast material completely into space. Sulfur and oxygen ions escape the moon's weak gravity and drift outward, but they do not disappear. Jupiter captures them. The particles become trapped in the planet's magnetic field, forming a glowing ring of plasma encircling the entire planet along Io's orbit. Scientists call it the Io-plasma torus. From there, the charged particles travel along Jupiter's magnetic field lines all the way to the gas giant's poles, powering auroras that dwarf anything visible on Earth. A small, violent moon creating light. Shows on the largest planet in the solar system. Juno has orbited Jupiter since 2016 and conducted multiple close flybys of Io in December 2023 and February 2024. Its infrared instruments captured Io's lava lakes in thermal detail never previously achieved, watching volcanic crusts crack and sink and reform between successive passes in real time. But every piece of data comes at a cost. If Juno entered the most intense part of Jupiter's radiation belts without protection, its electronics would fail within hours. The spacecraft survives only because it carries a vault of titanium shielding around its most sensitive systems. Even then, each close pass borrows directly from the spacecraft's remaining operational lifespan. We are learning everything we know about Io at the cost of the very machine doing the learning. No spacecraft has ever landed on Io. Lava temperatures, corrosive sulfur fallout, continuous tidal shaking, and Jupiter's radiation bombardment make a surface mission the most technically hostile challenge in all of planetary science. Every mission so far has wisely kept its distance. Juno flies past, studies, survives, then retreats, and the question it brought back remains unanswered. What exactly triggered the largest eruption ever recorded? Scientists are still studying. Whether it was a chain reaction through Io's interior or something deeper that our models cannot yet explain, Io is only slightly larger than Earth's moon, two worlds made of rock, nearly identical in size. One silent and frozen and unchanged for billions of years, the other the most violently active world in the entire solar system. The difference is only distance. Move a world a little closer to gravity and stone begins to melt. Move it farther away, and geological time freezes forever. Size does not determine how alive a world becomes. Position does. Somewhere in the universe, there may be thousands of moons like Io, worlds locked in gravitational prisons around giant planets, slowly squeezed until their interiors burn, unable to cool, unable to rest, condemned to erupt for as long as the gravity holding them never relents. For 4 billion years, Io has been one of them. The fire is not stopping, the interior is still burning, and the record-breaking eruption Juno witnessed may not have been an exception. It may have been completely normal for a world we are only beginning to understand.